Okay, so we are now going to continue on our conversation from last time as we dive deeper into probability. Tell me more about that probability thing we talked about last time. Tell me more about it.
What did we discuss?
Mutually exclusive independent coordinate. You multiply?
Absolutely. So, could you give me an example of a probability that is mutually exclusive?
You want to find if you're going to get, what's the probability that you'll get heads when you flip a coin?
And what would that be mutually exclusive with?
Or if you get heads or tails when you flip a coin.
Exactly, because you can't obviously get a heads and a tails in one flip. Right? Absolutely. What would be independent? Anyone? Nisha?
I'm sorry, what was that?
Unless they're dating or something, right? But yeah, in general, like two students coming to class, they're independent. You can wiggle with that a little bit. You can be like, well, what if there's a traffic jam or something? That could affect both of them. But in general, yeah, they're totally independent, right? One shouldn't matter. Maybe they're friends, but maybe they're not.
Great. So let's then move a little forward and
Talk more about this probability issue by talking about gambling. I have, just before, this die right here. What die is this? The D8. I like how you answer that. And what does that mean? Excellent. It's 1d8, right? It's 1d8. There's only one. But absolutely, it's a d8. It's an 8-sided die. Let's imagine, Michael, that we were to play a game. And the game is, I roll the die, and whenever it comes up, I will pay you that much in dollars. That was a 1. That wasn't very exciting. But it could be a 3, and I would pay you $3. That one was a 4. I would pay you $4. How much money would you be willing, what is the most you'd be willing to pay me to play this game? $4. Why?
Because the chance I can get $8.
Okay, so why don't you pay 8?
Because I just lose all the money.
So the most you're willing to pay is 1.
No, the most I'm willing to pay.
Most you're willing to pay is 4. What's that based off of?
I just picked it up.
Well, what we could do is we could ask ourselves, what can we expect to happen on average? Like if I were to play this game, I don't know, 1,000 times, what would be my average payoff based on that 1,000 times? Did you have a question, Ike?
No, I was going to say, maybe you're trying to say, like, that's what he's willing to part with. Like, if he loses 4, he'll be okay. But maybe
Oh, I see.
Yeah.
It's like, you never gamble anything more than you can lose.
Exactly.
Right. That's a good rule, but that means to be willing to, if he has $50, we're willing to pay $50. That'd be part of the story. I think it's interesting that it was the most you're willing to pay is, the most you're willing to give the 8, and he was willing to pay exactly half that. Maybe it's coincidence, but you're sort of actually, if it's not coincidence, you're also kind of honing in on what we're talking about today. That's expected value. Which is the average payoff of an uncertain event. The average payoff of an uncertain event. Or the value of the grand payoff.
You can think of expected value actually as a version of a weighted average.
It's a lot like a weighted average. In fact, mathematically, it's exactly like a weighted average. It is the probability of an event times the payoff if the event occurs. Or if the event happens. But a full understanding means we have to consider all of the possible events, right? We can't just look at one, we should look at all of them. So to connect it even more to a weighted average, we can say it's the sum of all of those individual expected values. Probability of the event times, I don't want to say payoff again, because that would be P again. That's annoying. We could say benefit. Oh, no, we should call it value, right? Because it's the expected value. Oh, that's even better. P times V. Well, that's the probability. And that's the value if I happens. And then you would just do that for all the different world states that could happen. So, for example, what is the chance of me rolling a 1 on an 8-sided die? 1 out of 8. And Michael, what would be your payoff? What would be the value if I get a 1?
You get one?
Yeah, if I roll a 1. No. I roll a 1. I'm paying you whatever comes up on the die. I lose $1, but I'm talking about you. What is your payoff? You gain $1. What is the chance of rolling a 2? And your payoff is now? $2. And we can just keep going, right? All of these sum products. All these sum products. So 1 out of 8, 4 plus. Let's put it down here. 1 out of 8, 5 plus 1 out of 8, 6 plus 1 out of 8, 7 plus 1 out of 8, 8. Does anyone know what that equals? $9. $9? Nope. Take 1 8 plus 2 8s plus 3 8s plus 4 8s plus 5 8s plus 6 8s plus 7 8s plus 8 8s, you get 4.5. So your guess was pretty close to the average. It is 4, it's actually 4.5. On average, you would get $4.50. If I were to play this game 1,000 times, I would pay a lot of money out. I would pay $4,500. Because every time I play, I pay off on average $450. Any questions? Yeah.
I guess if you were charging people to play the game, what would you charge them?
That's a great question. So, how much do you think I would love to charge them?
$8.
I would love to charge them $8. Would anyone be willing to pay $8 to play this game? No, I question your sanity or your math skills, if you are. I'm obviously going to charge the highest I possibly can and still get people to play. Well, my question for you is how much you would be willing to pay. Would anyone be willing to pay $4.50 to play the game? CJ, did you nod your head also slightly? You take a chance. Michael?
Yeah, that's a good chance. Some people say more than
Yeah, right. Unfortunately for me, that's like kind of not a great deal because on average, if I do this on average, I'm breaking even and nothing comes of it.
would you be willing to pay $5? 5? Yeah. CJ, would you be willing to go up to 5? Yeah. All right. 6? Maybe? I would take 6 in a heartbeat. I mean, I would, from my hand, I would take 6 in a heartbeat. How many of you would not be willing to pay $4.50? Raise your hand if you think $4.50 is too high. Right, would you be willing to pay 4? Right? 3. But you can't. I mean, obviously, yes. Obviously, CJ willing to pay 3 if you're paying 8. But we're looking at the other end. So what we've sort of identified is that there's a spectrum here. When I ask you how much are you willing to pay to play this die game, I'm not really answering the question by saying $4.50. I'm giving us something to work with. And how you approach that $4.50, what you see as that $4.50 payoff, describes your attitude toward risks. So this is language that's often used, especially in investment circles. And by the way, if you had like introductory macro with me and I talk about investment, you notice that I mentioned there's a risk-reward payoff. A risk-reward trade-off, risk-reward trade-off. This is an example of this. Because if it's higher risk, that means the probability of success goes down, which means in order to compensate, you need to have a higher payoff. While something that's very, very safe might have a very high risk, very high probability of success, which means you don't actually need to pay people very much to do it. And so it balances. So we have to get some definitions around, let's let A be a certain payoff. And EX be the expected value of an uncertain payoff. I need my eraser. Messy. Uncertain payoff. And finally, let's let, just for purposes of clarity, let A equal EX. So imagine I have two options for you. I have the die game right here, and I have $4.50 right here. And you can choose which one you want. You can either go with the $4.50 and collect $4.50 straight up, grab it, go home, or you can play the game. That's how we're going to measure this. And indeed, that's effectively what I'm doing when I'm asking you how much are you willing to play the game, because if you pay me $4.50, you are giving up $4.50 to go over here. Or if you don't want to play the game at $4.50, you are holding on to your $4.50 and opting over here. So it's effectively the same thing. How many of you would like that $4.50? How many of you, raise your hand, would prefer $4.50? If I had you choose, you don't have to pay me. We're just choosing between two things. There's a table over here with $4.50. There's a table over here with a dice rolling game. How many of you prefer to grab the money? Aiden would prefer to grab the money. Really, just one. Okay. Usually get more than that. Aiden, you know what we call you?
Risk averse.
Risk averse. I lost my black marker. All right, I'll find it. No, wait, I see it. I'm told the black stands out more, even though I find the black a little boring all the time. But that's okay. Let's just make it stand out. Risk-averse people prefer A to EX. They prefer the certain payoff rather than the uncertain one, even though they are on average the same. How many of you would prefer to play the die? I would call it a die game. I'm not choosing you between 450 and die. There we go, die game. How many of you prefer the die game? Raise your hand. Wow, a lot of you would prefer the die game rather than paying 450. Keep in mind, you could roll a 1 or a 2. Interesting. You guys are, compared to the last section, much more what we call risk loving. You prefer the uncertain payoff to the certain one. Now you notice I left a blank between these. How many of you are indifferent between these two options? We can play the die game, or we can just collect money. How many of you don't care, Anisha? Right. You are what we call risk neutral. You are indifferent. Between A and EX.
This neutral is arguably the most logical way to be, because of identity people. But that doesn't change the fact that some people just have certain joy in the thrill, as apparently a lot of you do. I'm going to roll the die and see what comes up. I'm so excited.
3. Sorry. Other people, like Aiden, are like, see, that's why I don't play that game. And they just prefer to hang on to the money.
Maybe if it was more. I said maybe if it was more money.
Oh, so you say it was the result times 10?
Yeah.
So that would be 30?
Yeah.
Yeah. Mm-hmm. And so what you're talking about, Ike, is there's this area of research called behavioral economics. And part of behavioral economics is what we call prospect theory, which is noting that it's not just, it's about how people's attitude toward risk changes based on not just how likely how big the payoff could be, but also how likely the event is. So like, people approach like the lottery in a very different way that they would approach insurance, even though like they appeal to different kinds of this. Like, lottery sort of appeals to people who are risk loving, and insurance appeals to people who are risk averse. The same people would do both. So, I mean, we're not trying to get into the prospect theory, but if you Google it, there's a lot of lottery is a super great example, and insurance is a super great example because both are really big results, but small things like this too also sort of play into that. And you're absolutely right. Yeah, if it was 45 rather than 450, I'd have a different opinion.
But you know, that number is going to take $8.
Right? Yeah, I don't blame you. There's a lot too. So, one of the reasons why people are risk averse is because of this other behavioral economics thing, and prospect theory has a lot to do with it. Is loss aversion. And loss aversion is this basic idea that if you like gains less than you hate losses. So the story I tell with my micro students when we cover this is let's imagine, David, that you're trying to get a job. What job would you love? No idea. Can you just pick something? Oh, that's a great job. I know a lot about that job. I can give you some advice on getting that job. So let's imagine that you applied to a bunch of places and you got a call, and they say, "Oh, we're so happy to offer you the job. Can you start soon? It'll be great, right? Are you excited?" Yeah, right. Oh, yeah, that's a great salary. It's fine. It's exactly what you want. 5 minutes later, they call again. This is awkward. We were going to actually talk to a different David, and we mistakenly called you. Sorry. Have a nice life. Yeah. How do you feel?
No, I'm the opposite.
But are you happier? Oh, I'm sorry. Are you as like this was before the first call? You obviously got happier. Are you back down to here? You're probably lower, right? Yeah. You're probably like, oh shit. You feel shitty now, right? You're worse off than if they had never called you at all. Right? That's this idea that this is the gain from getting something, and this is the loss from having it taken away. And so this idea that people have things, so, you know, we in lost version is often about like the counterfactual about like what you think would have happened, and that's why that complicates the story. But in this case is why a lot of people end up being like, you think like, well, I'm losing out on this if it turns out poorly, you know, but it's not a big deal. Who cares? It's just 450, but you're losing out 45 is a bigger deal, and that's going to really hurt you a lot. So it all gets tangled together. These things called reference points, loss aversion, and so forth. It's a very interesting literature here about it. But that's sort of the additional dimension of this, and these three terminologies are what guides us. So especially if you go into investment. Because I think that the only way to really seriously beat the stock market reliably is to have a better presence of mind than other people. It's not about being smarter, it's not about being faster, it's about being wiser. And understanding risk averse or risk neutral and risk loving helps you get there. Okay, a little bit of a tangent, but that was fun. Let's unpack this a little bit more. Over here. Because some industries are built on people being either risk-loving or risk averse. Casinos are such an example. I want to switch to green. Let's just see how green works out, because I want to mix it up some. Oh, wait, no, I tweaked you. Oh, that's pretty fun. So, a roulette wheel has a bunch of spaces on it, right? How many spaces on a roulette wheel? Does anyone know? 38. Good guess. Wasn't from the notes at all. So, and this, by the way, is an American wheel. The European wheel is slightly different. I think the European wheel is 37. The wheel is made up of a whole bunch of black spaces. I'm not gonna write 38 black spaces. I'm not gonna write all the black spaces here, but just to give you an idea, this is sort of what it looks like. All sort of randomly and evenly distributed. It also has a whole bunch of red spaces. I believe it's red, right? I'm gonna say it's red.
Yeah.
And if you're thinking, wow, some of these are like really big, they're just two right next to each other. And then there is this great invention as well with the green spaces. It's basically a roulette wheel. I love how they call the green spaces. You know what they call the green spaces? 0 and double 0. But that's 0. Well, it's double 0. Shut up. Now let's imagine you spin this roulette wheel, and you say,
I'm trying to remember exactly which ones are black and which ones are red, because it's not a simple matter of evens or one and odds or the other. Let me just pull up a picture. Okay, we'll say. What's down here? There we go.
let's say 28 black. Let's imagine I put my money on 28 black. And I put $1 down.
28 black comes up. How much money do I win? Why do you say 38? That's logical, right? So 1 out of 38 chance to get 28 black. That'd be nice. I get $38. But think about the perspective of the company, right? Think about the perspective of the casino. If we played it, if they did it that way, much like if I charge $4.50 to play my dice game, I would make no money. The casino would make no money. Right? On average, 1 out of 38 people get it. We'll pay them $38 if they get it and keep the money if they don't. That means that they don't get anything on average. So it's actually slightly less than 38. It's still high enough to make it really tempting and cool. It's not something as low as times 7. It's actually $35. You put $1 down, you get $35 back. That's huge, right? You put down $8 or $10. Sorry, you put down $10. You turn that 10 into $350. Ooh, that is awesome. That is sexy. That's exciting. Let's do a little math. What are the chances of you getting that 28 black?
1
1 out of 38. So if you win, 1 out of 38. That's our probability of success. What's our payoff? 35. Which means that is 35 divided by 38, which I believe comes out to about 92. So one thing that can happen is if you win. The other thing that can happen is if you lose. What are the chances of losing? And as noted, we paid $1 to get it, so what happens? We just don't get that $1 back, right? That's correct. I wasn't making a trick question. We put that $1 down. We say 20 black, and then it spins, and it's all very exciting, and the person says, "Oh, 1 minute. Thank you. Would you like to play again?" So we would lose $1. What would be that? Does anyone know? What is 37 divided by 38 times -1? Obviously, it's going to be negative. Anyone know? 0.97. So, what is the expected value of playing? Well, you can either win, which gives you 0.92, or you can lose. So we can add on a negative 0.97, not 0.95. We can add on a negative 0.97, and that results in what's 0.92 minus 0.97? Every time you play roulette, for every $1 you put down, you will lose 5 cents. If you decide to not put a simple $1 down and you decide to put $100 down, you are, on average, losing $5 every time you play. Hey, Jim, I'm going to go play. I'm going to put down $100. Imagine this game. I'm going to do that 1,000 times. Oh, you just give them $5,000. That is how they make it. Now, this doesn't mean that casinos are being dishonest. This doesn't mean they're being mean or evil. It means that some people love this thing. Oh, it's exciting. And they get a lot of joy out of that. And so in order to, be able to afford all the payouts, so you have to do something that is exciting. And then, of course, pay the rent, pay the maintenance for everything, pay the people who are taking the money and giving you drinks and all these other things. In order to make that function, they have to, on average, win. So So there's this asymmetry between the customers are risk loving, but the casino is risk neutral. Right? And that's how the exchange happens, right? And then people have lots of fun, and the casino gets money, gets a profit, all that stuff. Any questions?
I've seen the man that was like $1,000 and even the fortunes from the better drink can make more money.
Yeah, it's all about those high rollers. Right? I also love too, I think we talked about this when we did our first unit. If you were to ask everyone who's been to Vegas, how much did you win or lose, you would probably get a positive answer. Why is that? You probably get something like maybe $50 on average or $40 on average. Why is that? Well, then that means on average the casinos are losing money. I'm not sure people stop while they're ahead. Like if you lost $1,000, let me ask you this: if you win $1,000 at gambling, would you tell people?
Yes.
Yeah, right. Why not? Right? Why would you tell people?
Because it's so much, right?
Yeah, it's like awesome. I outsmarted the system, right? Let's imagine you lost $1,000 gambling. Exactly, right? People brag about their winnings more than they brag about the losing. So there's a self-selection bias. And so he says, like, how much did you lose? They're like, I just didn't really play. While they're like mortgaging off their house. That's not for me. So what this is supposed to illustrate is if you are thinking about, oh, I'm going to go to the casinos and make money, don't. Every time you play, you lose 5 cents. I'm not saying you shouldn't. If you enjoy it, that's fine. But keep in mind, in the long run, this is how they make money.
I don't even think you can put $1 down.
Yeah, I don't know what the minimum bet is, but sticking with $1 makes it, makes it mathematically easier and cleaner. Because then we can say, then you just whatever you actually gamble divide by 20, and that's what you're paying them. Other industries are not built on people being risk loving; they're built on people being risk averse. Let's imagine that there was and I'm going to use a simplified example to show you what's going on. There is a 1% chance that a person would get into a car accident. Let's also suppose that if you are in that car accident, the accident, it's a relatively minor accident, but it still costs $1,000 to fix the car. And that's just what exists as you driving around. What could you do? Are you scared of that $1,000? That really expensive cost that might happen anytime you might have a bad day? Are you scared of that? Is that kind of a scary thing? Yeah, it might not happen at all, but if it does, how many of you just have $1,000 sitting in your bank account? Could be a big problem, right? Maybe there's a way you could avoid that really scary incident. We have a way for that. Does anyone know what it's called? Insurance. Let's imagine I start a little insurance company. It's like, you know what? If this happens to you, don't worry, I got it. I will charge you premium. Use a slightly different number than I have in the notes. Our premium is, I will charge you $13. I will charge you $13 for this premium. And you pay me $13 every month. This is a monthly probability. And then if it happens, I'll cover the costs. I got this, guys. Would you be willing to do that? Or at least would you imagine people would be willing to do that? Pay $13 to avoid the possibility of shit hitting the fan. Absolutely. Well, what is the expected cost of a car accident in this scenario? A what? No, what's the expected costs? So you gave me the costs assuming that you got into an accident. I'm giving you, I want the cost adjusted for the likelihood it will happen. I think I heard it. What was that? $10. How'd you get that?
That's it.
Or the probability of 0.01 times 1,000. On average, each one of my clients, each one of my insurance premium holders will cost me $10. But they bring in $13. I make a profit of $3 for every person that comes in. Again, this is mutually beneficial, right? You get peace of mind. That's actually how a lot of insurance companies build what they're selling, peace of mind. You get peace of mind, I get profit. Right? I'm risk neutral, I don't care. You're risk averse, so it's a good deal for you. We're both better off. Right? You are essentially pooling your risks. And to illustrate, let's imagine that there were, I don't know, 10,000. Imagine there are 10,000 people who are in my insurance employ. 10,000. How much money am I bringing in total premiums? 130,000. What are my total costs of payouts? Payouts. So in other words, how many accidents, for example, do you think I will have every month? How many accidents do I have? 100. How'd you get 100? Exactly. So I would get maybe on average 100 accidents, because that's 1% of 10,000. How much does each accident cost me? $1,000. So 1,000 times the 100 accidents gives me $100,000. I have to pay out $100,000 in claims, but I bring in $130,000 in income. I make $30,000, which notably is the difference between this and this times this. The difference between these two is 3. 13 for the premium minus 10 for the expected cost, the cost per person. That's 3. 3 times 10,000 is $30,000. Insurance is built on people being risk averse. And laws that make you buy insurance.
This is obviously a simplified example, which is why insurance companies like to know things about you so they can adjust your premium rates. High-risk people obviously have a higher chance of accident, so they pay more in premium, and there's different kinds of accidents, and so on and so forth. There's a long list of stuff, and it gets complicated quickly. This is what actuaries do, is they figure out these probabilities and everything. But at the base level, this is what's going on. All right, any questions?
Great. So what I want to do right now is turn your attention to what we were talking about last time. Last time we were discussing this hypothetical about construction, if you recall. What was that again? Anyone?
Yeah, we did the probability tree, we did the consumption, what were the, what was the most common time it would take to do the consumption? 14. So, if you all have Excel, you can take a closer look at this.
Here's our total time, our probability for each option. So this is, of course, in months, 11 months, 12 months, 13. Here's our probability of 0.008, 0.076, et cetera, et cetera. Again, most of the action is right here, but there's a little bit over here, too. This is like a 90% chance it's going to be in here, or over 90% chance. But maybe you want to know not what is the most likely time, the way you can tell your client. Maybe you're curious, what is the average time? And the average time for each project is really helpful because it helps you schedule. You get a pretty good idea, right? So you want to know what the average time is. How would we figure that out? There's two ways to do this in Excel. How would we do this? Yeah.
Just taking people's average
Let's see. 13. That seems odd though, because we said that the most likely time is 14.
Doesn't it matter how likely each result is?
Yeah, right? Remember, we said expected value is a lot like the weighted average. So we can do the same thing we did with weighted average. The probability of this happens times this. Or it takes 12 months, and this is how likely it will take 12 months. Or at 13 months, or 14 months, or 15 months.
These are all of the component months, just like I had the component dollars over here with the win losses, which I covered up. You know, the 92 cents and the negative 97 cents. This is us taking those, remember, this is just like a weighted average. But now we're doing the sum of P times Q. So here I'm doing the individual parts, all the different scenarios. And then I'm going to add them up. So I was just taking, I realize you have to type this out, I already have this done. I was taking the total time it takes in months times the probability it would take that time. And that would give me expected months for this scenario, expected months for this scenario, expected months for this, et cetera, et cetera, et cetera. And then you add up all the different scenarios and you get 13.8. Any questions?
Well, can we go into faster than that? That took a while. You can also, of course, use some products if you want. It's not something else. It's a product. That one? That one? Same story. There's the mouse.
Or if I really want it, I can just move it over here. There we go. Any questions on this? It's pretty straightforward. Recall what we did before when we did weighted average. We divided by something. Remember what we divided by? Yeah, so it was, remember what was, our equation was, I should erase this wheel. Basically like a whole marker making that wheel. Our equation was the weights times, I believe it means x's divided by the sum of the weights, right? And expected value, the weights are just probabilities. And we would, just as before, divide by the sum of the probabilities. But what's the sum of the probabilities? Always 1. Because something has to happen. Something has to happen. So in this case, I can just use exactly the same thing. I don't have to worry about dividing by the sum of all probabilities because we know something has to happen. Any questions on this?
So we don't have time to quite get into, because I had a full application of respective value with the negligence of where it handled. But we do have enough to get through the application of prediction markets.
So I want to quickly give you prediction markets, which will take like 10 minutes. That'll be fine. And then I'll let you go. Have you ever gotten in a debate with someone about the outcome of something, like a sporting event or something like that? Yes. Who said that? Yes. Michael, I haven't heard. I can't remember that one.
What were you doing?
Sports.
Well, I don't know, like the result of Super Bowl or whatever sporting event might happen. I don't know what sport you follow. Yeah. Give me an example. Oh, okay. And have you ever encountered someone who was rather insistent that they were correct and you were wrong on this? And how do you settle these disputes? You just have to wait.
All right, I'm going to give you some advice now on settling the dispute. I'm going to argue with you that the Green Bay Packers are going to win the next World Series. Now, immediately, I don't know that much about sports, as you can probably tell, because why?
It's not a baseball team. It's a football team. So it's.
So I'm going to insist, but maybe I don't believe you. So just for fun, let's imagine that I'm a simulator, right? So this is the astronaut conversation. No, you don't understand. The Green Bay Packers are awesome. Packers! They win everything. They win everything. Now, the best way to shut me up is to ask me, does anyone know? If you believe that so much, why don't we place a bet? Right? Because obviously I'm not thinking things clearly. I just really love the Packers. I mean, I'm not a sports person, right? I have dice. But just if we were in that scenario, right, the best way to shut someone up is to ask them to bet. Because before, when they are arguing with you and they're wrong, they don't lose anything. But if they're wrong and there was a bet in place, now you may be wrong expensive. So what some economists have argued, including the person who came up with this, Robin Hanson, is like, well, we should allow betting markets. Not necessarily for sporting things that already exist, but for things that people normally don't bet on, like political outcomes. And then we can get an idea of what people actually think, because rather than just arguing back and forth, they put their money where their mouth is. Talk is cheap. And we can then use expected value to figure out what the probability of events are based on how much people are willing to pay, based on the price of these events. So the basic scenario is you create these digital tickets. And the ticket is, I'll make the ticket like that, invisible ticket.
The ticket is worth $1 if the event happens, and it is worth $0 if the event doesn't happen. So let's imagine we are betting on if Democrats will control the House after the midterm elections. And that's what this was. The Democrats control the House. That's what it represents. That means it's worth $1 if the event happens. It's worth $0. How much would you be willing to pay to purchase that ticket? Should it be less than $1?
Yes.
Yes. Why?
There's $1 that happens.
Mm-hmm.
So do you think, how many of you would be willing to pay 90 cents to buy this ticket?
Why?
Just because it's how
Sure, okay. Well, let me ask you this. Let's suppose the ticket was, if this die fell to the ground, if I let go of this die, the die will fall to the ground. That's how much the ticket. How many of you think that that's what's going to happen? I let go of the die, it falls to the ground. I hope all of you think that's going to happen. Right? We don't live in space. Right? Good. I didn't get a lot of hand raises. So that means that you would be willing to pay a lot. You'd be willing to pay about probably $1 because you're so confident it's what happened, right? What is the likelihood that if I let go of this die, it will fall to the ground? What do you think the likelihood is? 100%. So in other words, we can take
A probability times that value. The probability is 100%. The value, if it happens, is $1. And then we can get an expected value. In other words, that expected value ends up being the price. Because while you might be willing, if you're willing to pay 90 cents for that ticket on the Democrats will control the House, then you think there's a 90% chance the Democrats will control the House, right? Expected value is 90 cents, and then you solve, that's just the ones, the probability is 0.9. Right? However, Ike might just be very, very optimistic. So, other people might disagree, and we don't want to rely on one person, and thus the market emerges. In that market,
You could find it. I don't want to say it. I'll predict it. When you use real money to predict, so here is currently, because it is, what is it, April 19th, 2018. So this is when the special, when it goes on at 8, special, I've kind of seen it. I don't know what probability are. Looks like
it's you can spend 85 cents to say the Republican will win. That suggests there's an 85% chance the Republican will win. We'll spend 20, but this arguably should be 15 cents, but the market might be pretty volatile because it's pretty close, so it sometimes doesn't quite match up. But you can spend 20 cents if the Democrat means the Democrat will win 20% of the chance. Because this is all expected value. A prediction market is a speculative market designed so that, for instance, can be interpreted as probabilities of future events. I should say such that. since I brought it up.
U.S. elections. Obviously, he's not going to win because he says people out. Could have 1%, really? Really? 3% chance? Okay, I guess that's not fair. It wasn't just because this is sort of a wisdom of crowd story. It's not like any one person can move it. Though, of course, you can buy multiple tickets. This isn't only like you spend $1 at a time. People spend sometimes thousands of tickets on stuff. Where am I? I don't want to dress up power race. So, case of carrying inside.
They're currently trading at 70 cents. If you think it's 90%, you should buy. If you generally think that's the case. But also keep in mind, other people too are also trying to get that money, and they have reasons to think you're wrong. Maybe you are, maybe you're not. I don't know. But this is a neat application of expected value. By the way, too, at the value, there used to be one called InTrade that used values of 10 around 1. So obviously then the prices will be 10 times as large. But you would just stall for probabilities against probability. Alright. I gotta let you go though, I'm way over. So have a great couple of days, or have a great weekend, actually. I'll see you on Tuesday.